Okay, in this question we start with an equation of a line and some coordinates. I think if we can forget about those for now. For the gradient of AB you just need to look at the line, but this form of the equation doesn't directly tell you the gradient. That's most visible from the GCSE form of the equation, where y is the subject. If you make y the subject of the formula, and then when you've got x's and constants here, you should remember which bit of that to look at that tells you the gradient of the line. That's from GCSE. Then in A part 2, we've got to find an equation of a straight line. So we want the y minus y1 recipe. We need a point and a gradient. We know the line passes through A, so that will help with the point, and it's perpendicular to AB, so that's where the gradient's coming from. We know the gradient of AB, so we'll need a perpendicular gradient. Check out the later part of section 3 of your chapter to find out about perpendicular gradients. Then in part B we've got an intersection of the line AB with this other line. So we've got an equation here. Intersection is code for simultaneous equations. The other equation you need is the one you found in A2, because that's the equation of the line AB. So simultaneous equations here, coordinates of B follow through all the way till you've got a y and an x, because you need to give coordinates x and y in the answer. And then in part C, we've got a point C. We know it's x coordinate, but the y coordinate is k, and the distance from A, there's the point A, to C is 5, and there are two possible values of k. Now there are two ways to do this question, depending on how you're most comfortable finding distances. If you tend to draw a diagram for the distance with a right angle triangle in it, then that approach will serve you well here. You can draw your point 6 minus 2, and there are two possible points with x coordinate 2 that will have the right length. One will be below that point and the other one will be above it. So you can have two different right angle triangles. You know the distance, the hypotenuse of the right angle triangle, so you can work out the other sides and therefore find out how far above and below that point this one is, and then the values of k. The other approach is those of you that like just going straight to a square root form with some difference in y squared and a difference in x squared inside the square root. If you set up your normal pattern for the distance between 2 points using that method and say the answer is 5, there'll be subtractions in these brackets and one of them will involve k. You can get rid of the square root by squaring both sides of the equation, so you can get something equals 25, two sets of squared brackets, and then you'll end up, if you expand this out, with a quadratic equation that you can solve for k. So you've got a geometrical, diagram-based, or an algebraic approach, and both of them work.